怎么发链接呀？我在这儿分享。这是盯上我了，这是。
One key to look good. Look up there. Okay. Already 19 people in. I have 19 people.
这19个人吗？这么少的吗？这哥们儿也来了。不是我大胖子啊，是我这个麦离我的嘴比较近，我麦比较敏感，所以我呼吸声你听得见。大胖子其实也差不多了，这在家待了2年，也快了。有海绵套啊，有海绵套还是这样啊。海绵套只是去那种杂音的。 差不多就这样。但应该在等人来，等他们人到齐了就开始。咕噜湖，咕噜湖这哪儿啊？我怎么感觉这么熟啊？重点啊，这他还没说呢，我怎么说重点？他还没开始呢。今天主要就讲那个多线程 P 图，还有所谓的算力造假，还就是这些安全的问题嘛。基本上就是国内人比较担心的这些问题。这个会基本上是专门给中国人开的。啊，云南，我说这么耳熟。半小时，半小时不算快，半小时正常。我这机器都能到20多分钟，快一点的话，用一个超算，你这直接1分钟就 P 出来了。用一个400，不是400核，200核的一个。M2固态都是啊 ，NVMe 啊，主要还是 I/O 它跟不上。哎，我本来是想在 B 站播的，刚一开播，立马就给我掐掉了。B 站是真的快了。P 的图认啊。哎，我是不是调什么静音了？没有吧？没有，正常。哦，还没那啥，还没到点儿。我说怎么还有5分钟？早上好，各位领导，各位来宾，真实的一般系统。反正文件系统的话，还是那种对小文件读写、小块读写比较友好的文件系统，效率高一点。还在用官方的 P 图，如果你是轮 P 的话，其实差不了太多。但是，其实我觉得，就是如果你已经买了硬件的话，其实可以考虑还是用原来的方法 P。原来方法其实省电，它这个多线程特别费电，我感觉基本上耗电量是原来的2倍。当然，这个东西你 P 完了，硬盘也就不会再 P 了，所以多耗点电倒也不是啥硬伤。上 CPU，就看你怎么控制了，你自己不要抄的太狠就行。反正我的 CPU 是抄不了的。但是，就是对那种刚入场或者说还准备买新的这个 P 图机器的人来讲，多了一种选择吧，就是不需要买那么多 SSD 的。差不多就是我看他这个人，就这个哥们儿，他是被这个，他原来是个做 YouTube 上面做内容的，他是个英特尔的一个，应该是一个 PM 吧，就是项目经理吧，被这个 Chia 项目组给招过来 给他们做一些视频，做一些我也不知道他具体负责什么，但是他是后来就前两个星期差不多，上个月加入的这个企业。他原来是一个 YouTube 上面比较知名度比较高的一个做气压相关内容的一个 YouTuber。
We're here to scare everybody about why is John Michael on twice.
啊，他俩怎么在一块儿？他俩住得很近
Doing
吗？
things in the valley. Excuse me.
这俩人可能都在湾区啊，都在硅谷住的，跑到他家里头来了。这应该是他家，就是这个 COO 他们家里头。他一般是在他自己家里头的，不知道今天为啥这哥们儿跑到这人家里头去了。P2T 的，统一般256好像是最佳的，512和128好像都差一点。说说。
Welcome, Justin. You're on mute.
I said, well, this is interesting. You guys in the same room. Hi, everybody.
Hey, hey. We are live on YouTube and recording, so just FYI.
Good afternoon, evening, wherever you are in the world.
Exactly. Is it morning anywhere?
I'm sure it's morning somewhere.
Somewhere.
他们的
I think
人
East Asia,
员
maybe?
挺散的。
It's the Topo Chico crew? No, we're not being sponsored.
We're not drinking. Yep.
这老哥是晚上，这俩人应该跟我一个时区的，应该是下午。
Yeah, New Zealand confirmed it's still morning there by 1 minute, so
There we
we'll
go.
count it.
Well, I was saying it wasn't that early. I mean, Shani has already said good morning, right? Let's wait another minute or two for Bram.
我是不是又？我想想，不应该声音小吗？你说什么声音小？是我的声音小，还是他们的声音小？
So yeah, John Michael was down here in the valley for various reasons, so we figured we'd do this on one fiber optic link and make sure everybody could actually hear us. But easier than coordinating the live stream is letting John Michael do a couple slides that we're going to throw up. Wait another minute or two here for everybody to get
调
in.
到最大了，他的麦声音就不是特别大。啊，不过我声音调小一点也行，尽量跟他声音在同一个 level。
I think Bram raised his hand.
Oh, did you not get in correctly? Let me see.
他们在等那个 Brian Cohen。
Aha. He's been here all along.
I see a couple of really good questions from the user Zach. If you could do me a favor and resubmit those as several different questions so we can answer them independently.
We can just do it all. We'll just leave it.
Okay.
Let's just leave it all. You already did me a
Okay.
favor of bringing it over from chat.
你
Okay.
们有啥想问的问题？
I didn't realize
可以
that. My
Exactly.
apologies.
No worries.
他现在还能收集
Wait
问
on
题。
Bram's account to do chemist. And we'll get underway.
怎么把他的这个声音调大点？
Pardon the minor technical issues. I think it's the modern TV of, you know, hey, wait, is this thing on? Is this live stream working? There we go. And now Bram is connected. Excellent. Okay, everybody. It is now 5:02 p.m. Pacific time.
还没批完，我还没批完。
on the 15th of June. John Michael is here with me, though he'll also be presenting on the other account there. Bram is now on after some technical difficulties getting in. And we have Bill and Justin here as well. So today's topic is going to be faster plotting, things like replotting attacks. How do we think about them? What do you care about your K32s?
就是他
We would
讲
like to
今
keep it
天
on
的主
topic
题就
for
是
security and
快速
security
批
related,
图，还
especially around
有
plotting and proof of space and time.
一些安全
So
上的问
questions
题。
about, for example, pooling will probably not be answered.
今
With
天
that,
不会回
Brand,
答
you want to
矿
say
池
a couple
的
introductory words,
跟
and then
矿
we'll
池
turn it
协
over
议
to John
相
Michael
关
to
的
kind
问
of
题。
walk through the overall talking points, and then we'll start getting questions.
Yeah. So there are a bunch of
有什么
trade-offs
问题啊？
that were made in the design of plots, or well, not just plots, but how they're used on the blockchain and
这个
stuff,
速度
having to
本
do
身
with
就是
what
有
the
一定的
minimum case
差
size
别。
is and what the filter size is. And whether these are set to appropriate values has to do with a lot of just empirical questions, which we did spreadsheet beforehand. We have some new information. It's not that different from what we spreadsheeted beforehand, but it's interesting.
Yep. So with that, let's go ahead and throw up.
这得
a couple
具体
things
问
to
题
walk
具体
through.
分析
John Michael.，
完了再说吧。我先得这个听他们讲一下这个东西。
At a high level point is we have some faster and easier to use plotters now, and that's a good thing.
Yep. Also, it's really important to know that we both expected that there'd be better plotters.
他就说他们对这个整体就跟我说的一样，他们对这个整体还是一个积极的态度，正面的态度。他们也预料到会有这么一个，就比他们官方还要好的一个批图程序会出现。
There'll be kind of the memory-centric plotter, the disk, the HDD-centric plotter, and the SSD-centric plotter, and trade-offs between them. And so we're excited about the fact that plotting is going to be easier, especially because it's about time for folks to replot. With that, I'll turn it over to George. John Michael.
Hey guys. So yeah, as somebody who's been around since the alpha and
他说了一下，他们其实是做了一个妥协。他们这个现在的批图程序是要考虑到机械硬盘和 SSD 两种不同的这个介质都有一个差不多的速度的，所以他们才这么写的。像那个多线程的话，机械硬盘你不组RAID基本上是批起来是很痛苦的。
When we talked about speed ups and plot ups in the beginning, it was less about like what could be done parallelizing the plotting algorithm. It's more about the algorithmic improvements and the resource utilization profile of the different plotting available. And so one of the things we've seen, it's weird, we actually did a contest early on, and I think Brian mentioned that actually when we did the original contest for trying to speed up the plotter, we actually didn't get anybody engaged that were contributing to the code to try to come up with a new, faster plotter. But it's not surprising. Chia has grown tremendously in the last 3 months, and we have a ton of new people in the ring, and we have a lot of people that are really interested in doing Chia plotting development. And so just even recently over the last month, we've seen a couple different plotters that are taking different approaches. The first one is just parallelizing many more aspects of the plotting code that weren't parallelizable before. So before phase 1 was multi-threaded, but that was really the only part of the plotting process that was multi-threaded. And so
基本上简单讲就是说他们觉得这个不是啥问题了。
And you had to go very parallel with a large amount of
他主要论据是他这个写入数据没有区别。
Phase 1 is parallelized is that Bill and I did a lot of research with the RAM WJB branch, which you can still see in the ChiaPos repository, to get a sense of what the limiting factor was when you could throw nearly unlimited money at plotting. And so a lot of what drove the K32 size decision was actually doing this kind of parallel type of plotting, but only on phase 1. The other phases are a bit more complicated, and it was going to take a lot more time for us to kind of get to that. So we focused on choosing a K and then getting back to launching a blockchain. Go ahead.
Right, yeah, we were running on extremely large AWS instances in that case. 96 cores and 384 gigs of RAM.
Yeah, and we assumed they were running at about half the speed they should otherwise run because they were in VMs.
他的意思就是他们
Yeah, the fact that some of these new plotters are
之前用
actually
AWS 这些服务器都测过这些批图速度。
I've just played around with them on my development systems, and I've installed some of the new plotters and ran the code, and most of them are writing around the same amount of data. So that tells me that the actual amount of sorting and writes to disk, most of the time spent in the Chia plotting after phase 1 is doing sort on disk. And so that's one of the key things that were a place to look to start speeding up the process. So one is for systems that were already very optimized and had a lot of
啊，
temporary
它意
storage
思就
space,
是主要的
and
瓶颈
had
还是
system
在
outputs
硬
that
盘
had
读
kind of
写，
256
然后
gigabytes
这个
of
读写
storage
量没
which
有发生
required
变化的情况
per
下
core,
面，
and scaled that up, and DRAM adequate per
问题
system.
不大，
They're
因
not
为
seeing major
你的硬
changes
盘的
to
读写
terabyte
速度
per
把这个
output
东西
of
就
those
卡死
systems.
了。
And what these systems do, which is very welcome to the community, is actually increases on systems that didn't have balanced resource utilization. And that's a lot of systems because it was very, very hard to get exactly the right amount of compute, storage, and DRAM on these systems for plotting. This allows you to take advantage of multi-core systems without either a large capacity SSD. Now, reminding you, you still do the same amount of writes, so high TBW SSD is still very much required, and those are not found generally on small capacity SSDs unless you're using something like storage class memory. I give some examples of the Intel Optane in the plotting spreadsheet that will kind of show up here in a few seconds. We actually got a lot of good results here from the community over the last couple weeks in some of the new plotters. So for one, multi-threading is very good. So now you can have a different profile. Some people are finding out that if you get over 100 gigabytes of DDR4, you can make a small temporary RAM drive for TempFS, and you can use that to kind of suck up a lot of the writes. This actually helps with a lot of the saving on the writes to get better cost utilization for making plots. So these are all amazingly good things, and we totally support them.
啊，他就说了一下这
One
个
of the
新
ones
的
that
批图
everybody's been
程序
talking
的
about
优
is this
点，
Max plotter.
比较省
So I played it
SSD，
myself.
可以用
We
内存去节省
I did
SSD。
a YouTube on my personal YouTube, kind of looking at some of the results, and we have some results from the community up on the spreadsheet. I can,
他这个人主要是测了一下这个新的，他有个视频是关于
It's part of the
测试
standard
这
Chia
个
wiki.
新
But
的
now we have
批
a
图
bunch
程
of
序
data。collected from a bunch of different systems to see how this thing scales. And yeah, so for one, it definitely allows you to take advantage of different system types, which will help reduce plotting costs and improve plotting efficiency for many people. We don't think that this is some massive algorithmic improvement. It's just parallelizing a lot of the things that we thought was kind of low-hanging fruit. We're happy that it's been
我觉得这哥们儿开始有点逞强。
That's the first part.
他们觉得这东西
Second
不是一个
question
特别大的
we've been
优
seeing in the
化。
chat, quite a bit, and we'll talk a little bit more about exactly kind of what the numbers mean and where do we baseline things. Obviously, the single plot time is the one that's changed the most. So prior to the Mad Max plotter, I on a Rocket Lake system,
家用电脑适合服务器就是洋垃圾比不了。
for a total plot completion time, which again that was just with the stock Chia POS plotter, and so now we're seeing times kind of sub
这
1,000
估计最近洋垃圾又得
seconds.
涨
There's
价
people。been massively posting this video to us of this Oak Ridge supercomputer doing a parallel plot.
他讲到那个了。
The total plot in 64 seconds.
他讲到那个人用
I did have a chance to
就是超级电脑，
Mad Max,
超级电脑
on,
60秒
the other
批出来一个
day, chat a
图。
little bit about this to see, for one, do we think his code scales like this? Two, is it really massively parallelizable? Three, is it real? And the jury's still out on that. I can't make a comment of if is it real or not, but it appears the output may seem like it could be in the realm of possibility.
他也不太确定那个60秒 P 图的真实性，但他推测应该是就是全部都是在内存当中完成的，不然的话他那个读写 I/O 读写应该是跟不上。
So yes, the code is scaling very well for single core time. Now this is definitely a different way of thinking about the plotting problem because you don't have to think about it as much as a power loss previously would have taken down however many plots you were doing in parallel and had to restart because there was no pause and resume. So this is now if you're doing one at a time, this is much better in that regard. It'll definitely change some of the tools in the community like Plotman and Swar and some other resources.
反正核心就是他们没有打算废掉 K32 的打算。
The question we've been getting, the number one question in the chat, on YouTube, on all of Keybase is, will we be changing K equals 32 anytime soon? And hopefully we'll walk you through some math that we went through just in kind of how we think about this. And Gene mentioned, how we chose K equals 32 as the minimum size for the network had to do with some forward-looking projections on what we think people could achieve, at what cost, at what system utilization. So we'll kind of go in and describe some of the systems we think that can do this in a small amount of time and whether or not that's actually a problem for the network.
他们觉得大多数人应该都没有那个超级电脑那个超级计算机的那个条件，所以说他们不打算废掉这个 K32。
There's something called a replotting attack And this is really not so much of an attack as it's trying to game the system. You're trying to turn Chia proof of space and time into proof of work by saying, okay, if I get a challenge, I can basically try to compute
这讲那
a proof
个
about a proof in
就是我
response to
说的
that
暴力
challenge.
验证
Today is about 30 seconds. about 3
，replotting
seconds.
attack。
So this attacker has the advantage of the plot filter. So what the plot filter does is basically
本质上讲是把这个 POST 时空证明转化成了 POW， 这是工作证明。
I believe the plot ID and the signage pointers. Yeah. And if the result of that hash has a certain amount of zeros, it passes the
256好一
filter,
点。
and then it can go in and you can do the reads on the disk to see if you have a valid proof.
省内存。
So the plot filter is very good because this significantly cuts down the amount of I/O you do in actual real farming and harvesting by a factor of 512. That's what it is set at today. Now this filter works the opposite way for somebody trying to do this attack because they can read, they can figure out what the challenge is, they can figure out what the filter is during that for every single signage point, and they can try to calculate one hash that basically proves for the 3 signage points within that sub 30 seconds. So okay, this is a good advantage for this attack, but we'll see why we don't think this is still economical for many different reasons. But so just because you can produce a phase 1 under 30 seconds, this does not mean you automatically win. We saw some people that were probably a little bit confused about this, that they just said, okay, if you somehow magically do a phase 1 under 30 seconds, you instantly win every single challenge. That's not true. It's still the way to think about this is that basically you're like kind of trying to pretend like you have a certain amount of space because you're basically trying to calculate the plot in real time as it comes in. Now it turns out storing data
他在
on disk
讲这
is
个
very inexpensive and
实时
very
批图
efficient.
叫 real
That's part
time
of what how
plotting 的
of space and time was
一
developed
个
is that
原理是
this is
啥？
the way that it's securing the blockchain, in that these plots just sit on the hard drive, and when you're harvesting, you just read them when the challenges come in, and this filter reduces that by a large factor. So when you're trying to do this in real time, it becomes a very challenging problem. So one is that without massive changes to the actual k equals 32 or the way that we have constructed the proof of space today, this still consumes a lot of time. One is compute, is write bandwidth, and memory. So when you're compressing that into a very small window, your amount of data you're writing goes up exponentially. And this becomes a very hard memory bandwidth problem, becomes a very hard disk problem. You need a lot of temporary storage space. So k equals 32, today you need 256 gigabytes of temporary storage space. That was one of the reasons why k equals 32 was chosen and not a lower k value. And that was a big, people that were on the testnet may remember this because there was a time when k equals 31 was kind of on the cusp. But getting that amount of DRAM to fit a k equals 32 in memory was much more obtainable than it is for k equals 32. So say for instance you do have a, I think what we're thinking about is a lot of people are asking the question is like, can this be done on a GPU? I think Mad Max himself in the comments on the GitHub say something along the lines of like, I've done some coding on OpenGL in the past, OpenCL in the past, and porting things to GPUs. So it's a question of, do we believe this can be ported to a GPU? Will it be hard? Probably. Will it be done someday?
他不会，就算他们的，就算这个3到5年内硬件可以实现这个30秒 PD 阶段，这个东西应该还算是相对来讲比较安全，主要是考虑到成本问题。
And the other knob that we have is the filter value. And we'll kind of walk through in a few examples of like what those do and where the the financial incentive would be. But it wouldn't be a problem if just because some person can do this on a supercomputer does not mean that the network is at risk. Does not mean that they can financially attack the network in some meaningful way. And the other thing is the only real problem is if very low cost consumer grade hardware can do this, then we actually aren't just totally hosed. There are a bunch of knobs in the protocol that we can do.
Yeah, and I think it's important to know that part of the reason why we chose K32 is that it became very clear to us that total memory throughput was going to be the actual ultimate limiter on how fast you could parallelize a plot. So, if you have the ability to borrow a $150 million supercomputer that's designed to be massively parallel and otherwise is supposed to be modeling nuclear bomb explosions, you'll get under 30 seconds. But it's $150 million, and make sure Uncle Sam is aware that you're using it, please. What that does mean, and I'll read a question from Colin Williams.
他们用的超级电脑1个亿。
I ran some calculations and suggested Chia's bottleneck for what I refer to as real-time plotting. I'll just change what he was saying.
我觉得
We're limited in
那个
practicality
里
by
边
RAM
用的
bandwidth and up for
60秒
cost.
P 图那
But
个
even
设备
future
应该没那么
DDR5
贵，
HBM3
它
not
就
fast enough
200
to
多
be
个
practical.
核。
Is there other hardware limiters aside from throughput bandwidth you foresee? And I think the answer to that is generally no. I mean, it is RAM time to GPU, right?
Yeah, and the fact that is like, how well does this code port to a GPU?
看看这是个问题。
Even if there's slight inefficiencies, like the small time window that you have to make this attack profitable. So there was some other nonsense we heard on Reddit, and not to. A lot of people are really thinking about this and trying to learn, which I am very excited that people are actually trying to dig way deeper into the protocol. But you know, basically saying that okay, if this can be done in a GPU, was the whole thing just broken? And that the financial incentive shouldn't be enough. Well, that's part of what this has been.
感觉这人讲的好像有点自相矛盾，我也不知道是不是我听错了。
Aware of the protocol since the new consensus. It was in the document, so it wasn't like these were, and there's deliberate trade-offs that were meant to make this not profitable. So it's not like that it can't be done. It was the trade-offs are meant to make it not economical by a very, very large margin. And we'll show you just some very quick spreadsheet math that I did that basically proved that is the case.
Yeah, and you know it's important. Like this morning, IDC was out with a report that
我觉得他们现在
in fact, RAM
底
was
气
really
不太
bad, and
足
there's
啊
a。lot of stranded storage. And so fundamentally, you're talking
就是
about
他们
taking
现在
leading edge
觉得这个
hardware
东
that's
西
not
是安全的最大的理由
basically
是
you're emulating 50 terabytes. So,
如果
you know,
你
you're
想
not necessarily getting a
这
speed
个
up
怎
from
么讲？
that.
你想暴力
And
破解的
50
话，你的
terabytes
成本会
is
很
going to be
高。
competing with people who have 50 terabytes
但万一
today
就是要
or
是
otherwise
就是
funded.
有人有
Plus,
这个
the cost
闲
of
钱
storage is going to continue to go
想
down
干
in
这
the
个
next
东
few
西呢？
years. So there's two kind of pieces
我觉
that
得这个
factor
理
in,
由
you know.
理由不是太充
Unfortunately, I
分。
think a lot of people get stuck on revenue and not profitability. You know, you can absolutely choose to unprofitably try to emulate storage, but even if you're an attacker, you kind of want to have the most leverage per dollar per attack, and that answer is generally storage.
Yeah, it's worth reiterating that this is very, very apples to apples here. That if you do
听听他咋说。
a grinding attack on plotting, all that you're succeeding in doing is having the exact same share of the network as if you had a certain amount of space. There's literally no extra benefit to you whatsoever. So you're always making that decision about which of these two things do you have, and is this profitable for you to do?
And related to that, someone asked, is 2 terabyte per second memory bandwidth fast enough for real-time plotting?
Let me maybe go to the next slide, but and then I can kind of go through some of that. But before I leave this slide, you know, the words that are in green are, you know, the entire Chia company was founded on the
对，就是如果有人暴力破解的话，基本上就是把这个，我刚才说的一样 ，POST 转换成了 POW 的这个问题。他们应该是不会妥协这个的。也，我觉得潜台词意思就是说，如果真有人这么干的话，他们可能会采取不惜一切代价去把这个东西给堵住啊。
You know, I'm not going to bore you with the spreadsheet. We do want to spend some time.
我觉得这个应该是可以补的，可以补救的，不是什么太大问题。
And you have the plot filter 512. You can basically look at the phase 1 time, and then you can look at what the attack's percentage point is, and then you basically have about 3 signage points to respond.
这是他自己做的一个这个攻击测试吧。
And plus the filter. In the attack's percentage point. So this is a benefit to this this vector of attack. But you'll see one of the things about GPUs is
Space Mesh 那个我看过一眼，还没深入看。
large amount of power consumed.
最近事儿有点多。
In farming, the actual capex, or we call this capital expenditures in my world, but really you guys just call it cost of like how much money does it cost to buy the hard drives? That is the majority of cost in Chia farming. Many of you know this very intimately.
这谁在乎这点电钱？他说这个东西要600瓦，比较费电。只要能挖出来，谁关心这点电费啊？
Hyperscale data centers, it's actually less than 10% for storage. They are very, very efficient.
我觉得这理由不成立。
In proof of work, it's the exact opposite. Most of the money is actually spent on the operational expenditures for the power of actually running the equipment, and less of the money is spent on the actual capex of the hardware itself to use. Now, it's probably they're both high, but it's a much different ratio versus farming. So this is a very, very important thing in this attack, because you have to model what the power of the system would be. You have to model the cost of it, and then I've modeled just my bandwidth of what I think you need as far as to hit a certain number of seconds to complete a plot for phase 1. Now, why is it phase 1 and not the whole plot? Well, hypothetically, somebody can write out phase 1 and try to farm off of it. Now, we don't believe that anybody has done this, we don't believe that we've seen any software that can do this today. It does become more challenging because you can't use the standard software that is already written to basically do the harvesting and farming. So, for example, we'll just start here because this is the one everybody's been trying to talk about. So if I were to buy this supercomputer for $100 million and it runs at 9 megawatts, I just did this back of the napkin math, and they said they have 4,608 nodes, which is a very interesting number for us. But that is actually the number of nodes in this Oak Ridge supercomputer. And then they have a certain amount of GPUs per system. And I just said, okay, what's the total power of the system? 9 megawatts is kind of what I came up with the back of the napkin. It doesn't really matter. This is just fun. So if we were to normalize it, and this is the metric of goodness here, which is like,
但我觉得这人并不是用了超级电脑所有的算力，他只用其中的很小一部分。
And you divide that by the total amount of terabytes you have, and then you try to look at that over a time frame. So most people that are buying hard drives for farming are actually buying those in the intention of farming them for many years. If you're not doing this, then you're not getting the full value out of the plots you made. That is really the legitimate way you should be doing farming in Chia, is that the plot generation is a one-time thing. You can farm off them for many years. And so you can see here, it would be very silly to perform this attack, even though it can complete a phase 1 in 25 seconds. That system could emulate 57 terabytes.
就是从长远来看，你这种暴力破解的电费要远远高于就是你 P 一张图的电费，然后一直放在那儿，这两个成本相比确实比较大。就是这种暴力破解，你在挖的时候，你是一直在处于非常高的功率的在费电，但是正常的那种 P 图的话，你就是 P 的时候可能功率高一些，挖的时候功率很低，所以时间一长，这两个的差就会很大。它大概是这么个逻辑。
Now, the way that we're thinking about this is, at Intel, I spent a lot of time. I was designing the SSD controllers and the SSDs for PCI Express. So I know a lot about PCI Express bandwidth. PCI Express Gen 4 is 16 gigatransfers per second, and then you multiply that by the number of lanes to look at the total bandwidth. PCIe is bidirectional. If you were trying to perform this on a GPU or any type of system, you actually need memory bandwidth and PCI Express I/O bandwidth, because you have to move data around either from data which you're processing on the temporary storage that you're using to calculate the plot, or in memory, in DRAM. And so today, if you're doing DMAs or memory access for PCI Express, you're over the PCI Express bus, and you're limited by the actual physical number of lanes times the speed of those. And so we said, if for instance a PCIe Gen 4 GPU that is out today, a very high-end card, maybe a 3090, whatever it is, $1,000 card, if somebody was able to perform this and get to a phase 1 time of 30 seconds, again, they could spoof 47 terabytes of storage. And again, that would only, even at $3,000, they'd be spending $858 per year to keep that powered on. And the total cost of ownership would be $2.56 per terabyte per month. So that is about 10 times more than, so one, the question is, if somebody can pull this off on a GPU and get the phase 1 time below 30 seconds, if that is possible, which, in the next 2 years, maybe we see somebody that comes across and does this, it would still be about 10 times more than the current farmers are paying for the storage. So we don't believe that anybody would try to go purchase dedicated hardware to do this, because it would be vastly.
他说，如果用 GPU 3090挖的话，你的成本大概是你收益的10倍。所以他们觉得不会有人干这个事情。
People that already have hard drive space, and they're going to utilize that for Chia farming. So the marginal
没什么太重要，他就是在解释为什么这个东西是不可行。他们认为是没人会干，不是不可行，是没人会干。从经济角度来讲，没人会干。
If you were to go buy this storage new, what it would cost to do farming, and so if you were to just say this first couple of lines are just hard drive only, like not including anything else in the calculation. These next ones actually include like things you would need to actually farm, like cables and a JBOD and other things in that calculation. And then this last one is farming and plotting. So it's not necessarily just fair just to say, oh, you're just going to spend money on farming hardware, because people actually have to spend money on plotting hardware as well. And then you amortize that over the equipment, over the amount of time you plan on farming. And you can see, most of these farmers, if on the low end, are able to get to about 27 cents per terabyte per month. Now that's very good. If you're a farmer and you're getting to this 27 cents to 42 cents, most of the farmers probably sit in this range, and the ones that are coming in by new dedicated hardware today are probably towards this higher end of the range at 60 cents. And it would take a PCIe Gen 5 as GPU running with 256 gigabytes of DDR5. And by the way, I'm working with other experts in this space to see, we're doing some pathfinding on this GPU plotting to see, one, if it has legs, and two, what the theoretical bandwidth would be. But you would need PCIe Gen 5 to do a plot in 10 seconds, because the actual theoretical bandwidth is 58.6 GIB per second.
他这个人他在跟一些专家在研究就是这个 GPU P 图最快到底是能到多少，或者有没有可行性。反正他们现在应该已经开始重视起来这个东西了。
Accessing that across the PCIe bus, or in the future, if you had
他们估计现在他们的态度还是认为这个东西可行但不实际。
You'd still need PCIe Gen 5 by 16 to get anywhere close to that bandwidth. And even then, if you can do a phase 1 in 10 seconds, you're still about 3x the cost of what the average farmer is going to be. So
不是说你这个30秒之内批完就行了，就是30秒之内你批，你并不知道你需要批成什么样，你只可能知道一个大概的样子，因为你只有那个过了初筛的信息。就是这么说吧，就相当于考试你抄别人卷子，然后现在呢有一张考卷，它100道题，他做了20道题，那你现在可以抄这20道题，然后你很快能抄出来，但剩下还有80道题，你不知道怎么答。然后这个考试可能需要60分及格，所以说你还差40分，你这40分你还是得想办法通过别的东西花时间去解决这个问题。然后他的想法就是这40分他就全靠蒙，就是说全靠就跟那个比特币挖矿 POW 一样，就是不停的疯狂的去蒙瞎蒙，能蒙出来的话，那他就。
To do their real business, but when it's not doing the real business, to do farming, and in their case, they also do GPU Ethernet.
为什么怎么老有人说我是个大胖子？
So yeah,
只是我的麦比较敏感而已，所以我呼吸声你能听到。我离麦远点。
Again, this is one of the knobs we will have in the future. If somebody gets close to be able to perform this, we will make it very, very unprofitable to do it, because we do. There is.
今天不讲矿池的信息，今天没有矿池的信息。
Just go in here and play with the math and see, has that giant multiple effect. So it's very detrimental to anybody trying to perform this attack if the filter gets changed. So, one, if people go invest and try to make this happen, and then the plot filter changes, then they get screwed over pretty drastically right away. So,
yeah. So let's go ahead, Bram.
So I'm sure people are going to have questions along the lines of, well, what if things change in the future? What if, like, as technology improves, the ratios between these numbers get way out of whack, and we need to do something? Like, what might we do? Two things that are the obvious things to do are to increase the minimum K above K32, or to decrease how aggressive the filter is. So right now, the K is high enough that it's kind of annoying. So like doubling it or something would increase a lot of annoyance to people quite a bit in the process of doing that. And would obviously invalidate people's plots, which would not be pleasant. However, for the filter, right now the filter is extremely aggressive. It's each plot once every signage point, once every roughly 10 seconds, has a 1 in 512 chance of needing to do a lookup. So like less than once an hour per plot are you doing lookups. This is on the theory that this might be on an HD that's doing something else and you really don't want to distract it. But at the current level that it is, like multiplying that by 2 or even like 16, it would probably for most systems barely be material at all. So if we're going to change something much more likely, we're going to be making the filter a lot less aggressive than that we're going to be increasing the case size.
Yeah, and it's important to add.
啥时候给
filters
H
really about hard
铺
drives.
啥时候
If you
给
think about the next
H
5 to
铺
10 years,
背过
the switch
书
to
啊？
SSD,
我咋不知道？
SSDs kind of don't care, and so really the filters almost
没有
pointless
吧？
when you move to an SSD world.
Yeah, if the filter were changed to like 1 to just
出筛优势
no way to how never
很，你统计过概率
The
你就
filter
知
is
道
the
了。
leverage, and that's actually a
过
question
出
I
筛
wanted to
很
answer that I
容易
saw.
的，
People were like,
出
"You
筛
need
过
to
了
adopt
之
table
后
7."
还有万分、
To be
10
very
万分之
clear,
一的概率你才
the
能
way
爆
the plot
块，
filter works is
或者
it
更
basically
更
says,
高、
hey,
更
the
低的概
hash
率。
of the signage point
出筛是很
challenge
容易过的一
and
个
the
东
plot
西，说
ID
白。
needs to have 9 zeros in front. It's a little bit like Bitcoin.
他刚才说了，就
It
是
turns out that you can do enough hashes even on a modern computer that you
大
can
概有
actually find probably
512
2,
分之一的
maybe
概率会
3,
过出筛的，
of the next
每10
signage
秒
points that
钟
you pass with that plot
你
ID.
可以算
So
一
you
下
can。kind of jump them together. I think in reality you probably only do 2 at a time. So it might even be that all these costs are double.
Well,
Because you're
at
going to have 2 machines.
any given moment,
他
there's
刚
going to
他刚才
be
在
a
讲
few available, a few
为
signage
什么
points
不
that are active
不淘汰
because
这
you
个
have a few
K32
signage points worth of time to get stuff
我
into the
其实我听出来他的感
Let's see.
觉，
Let's take some
他
more
其实有点
questions.
想，但是一淘汰
Let's
K32 的
talk
话，
about
我
Mad
估计
Max.
很多人会
A lot of questions
闹，
about Mad Max. Bram,
这可能麻烦更
is
大，
Mad
所以他们
Max
现在就凑合先
significantly less
K32 吧。
effective for the same K32? What's your take on that?
So the Mad Max plotter, just in the interest of
是，我
speed
觉
and
得
also
只要
just
是
implementation convenience, it's
淘汰了
getting right now.
K32 的话，对他们来讲肯定不是一
Occasionally
个啥
drop
好
some
消息。
entries per table. I did some back of the envelope based on my
但他们
own
也得权衡，如果
understanding
因为不淘汰 K32，
of
然后
what he's
后面有
doing,
人真的搞出来一个什么
and
暴力
figured
破解
that
的东西，
probably losing
对，
about
那他们
a
这
tenth of a
就彻底
percent
没救了，我
of
感觉
all
就。
challenges.
那还不如
So
淘汰
if you have
K32，
a Mad Max plot,
就
the
是保
rewards
险
it's
一
going
点。
to
虽
be
然
getting are going to be a tenth
短
of
时
a
间内
percent
得罪一些
lower
人，但是
than
长期来
plot that
看
was
还
made
是
by
一
the
个保
reference
守的方案。
Now it will be a smaller plot, but by a much smaller amount than a tenth of a percent. There's this thing where things that happen to get dropped, but from the first table get a factor of 64 reduction. And
基本上是1倍以上。
increase in the number of things that miss versus the amount of things that were dropped. My guess is
假算力有很多种的，这个
rarely,
一下两下解释不清
there's
楚。
usually a way that's kind of annoying from an implementation standpoint.
有些只
Of
是纯
implementing
粹
it
就
so that
是
it detects
太
that
噱
rare
头，
case and does something slower in that rare case and doesn't take a real performance hit. So my guess is
有些是真的假
probably
算
it's
力，
possible to fix this without any
就是有些是骗不了矿，连矿池都骗不了的，
slowdowns in speed.
有些起码还
But
能
that
骗一
said,
下
I
矿
don't
池。
think the amount that's dropped is terribly material or concerning to most people, although it would be really nice if these things were byte for byte with intervals.
废掉是保守方案吧，就
And
是
some of our
最
trusted
安全
farmers
的一
and
种
others
方
have
案。
been working with it. When you run
但对
plots
他们
check,
来讲
Chia plots
肯定
check
不是
at
最
very
好的
high,
方案。
levels, you see a pretty good comparison for a Mad Max plot. And we've only seen people who've run really high numbers see
他们可能还想抢救一下这个
1% or less
K32。
in the total number of successful plots that check on a Mad Max plot. So I caveat that we're still looking at it and we've not been focused on it because
我
we
觉
have
得
this
主要
other
原因
thing
是因为
that
K32 批起来容易，门槛低。
I
K33 你
expect
需要
the
的
Mad
这些
Max
内
plotter
存啊
plots
什
are
么
good,
的硬盘
and
啊
we've
都
already
会
said
高，
that we expect to
这样不利于
pull
他
that
们
in.
前期的
There's
这
some integration
个
things
算
we'll
力
have to do
增
to
长
make。sure it works right and can kind of not blow up the Mac or other things. We want that stuff all to be
就
right.
像这个
But in due time, we expect that we'll be pulling that in as
散
well. I think there
户
are other
门槛高
optimizations.
了，
I've teased the team here that I think we're going to have a
对这个东西
plotter
不好。
config.yaml because there's going to be a lot of different kind of knobs and choices you're going to be able to make.
Yeah, there's a bunch of different things you want out of plotter. You want it to work
K35
everywhere.
你
You
都
want
未
it
必
to
能
be
装得下
super
K35。
robust. You want it
这
to
3.5可能都10几 G 了
byte
吧？
for byte identical outputs. You also want it to not use a lot of space while it's in the process of plotting, not have too much overhead there, which, you know, when you've got plenty of space, it doesn't matter. When you don't, it matters a lot. So there's a bunch of
但
dimensions.
我其实觉得这个
which
东西
some
并
of
没有
them
那
in
么
Mad Max, is
严
not
重
yet
啊。
as good as the
其实我
reference
能早就预见到这个事情会发
Not
生
yet ready for
他们估计也清楚这个，
Yeah,
就是你但凡在这个行业干过，你都知道。 就是他们这帮程序员啊，肯定不是世界顶尖的程序员，这点我估计很多人都认同。就是你最顶尖的程序员不会去干这个区块链去。那话就说回来了，如果有一个就是天纵奇才的这么一个程序员闲了，然后去看他们这个算法，看了一眼，发现哎有好多可以优化的地方，他优化了一下，那肯定就比他们这帮人做的要好啊。这我觉得很正常，太正常了。
Well, for the early adopters and people that want to start testing it, you can do it right now. You just pull down the GitHub and compile it. And there's a lot of tutorials already to go do that. So, yeah, our official
所以
stance
说
is
你
letting the community
不要对
try to
他
hash
们
it out
要
right
求
now,
太
and it
高
seems
了
to be doing a very good job.
他们这帮人
Also, I also want to add that
不是业界，
if
最
you
起
are
码
trying
不
out
是
all
业界
these
顶尖
third-party
水平。
plotters, I mean, we haven't vetted them necessarily, but I mean, it is safe to use them if you're plotting to your public keys. You can have an isolated computer. Malware can't hide in plots, so if you can take those plots on isolated computer to the public keys, they're fine to test with.
There was one question, you know, does the Mad Max plotter not pass the plot filter as often? It's almost impossible for that to be the case. It should be that any plot, the way the plot filter works, it's going to pass the same amount. So that should be an anomaly if you see that. Let's see.
Yet have like the ideal diagnostics, because what you would really like to have for something that's dropping stuff is be able to take the reference implementation and make a plot, and then something that you know is not making byte for byte identical outputs, and have that make a plot as well, and then run the exact same challenges on both of them and see how many things are lost by this other thing. And that way the just general noise in the number of responses that are happening is removed from the thing, and you just have noise in terms of how many things are dropped from the one that's not.
Actually, I think we do have a community member, Computer Whisperer, who's doing that exact thing, but it's just taking a lot of time to exhaustively search through all those challenges.
Yeah. One note, we're taking
他们
questions
就
not necessarily
讨
from
论了一
chat
下
on
这
Zoom,
个
but from
新
the
的
Q&A
P 图
system,
软
so
件
please,
P
if
出
you
来
have
的
questions, put it
图
there or on
能不能
general
报
in,
块儿之类的问
GN
题
Network Public
应
on
该是
Keybase.
没啥。
Let's switch gears
没
just
啥
a
太
little
大
bit.
问
I
题。
am going to bring up one pooling topic, Bram. People are concerned that plot pooling will make it so that other forks or other chains can't use our plots. Can you tell us about what we've snuck in?
Yeah. So we have a plan. So we most definitely want to support co-farming by other cryptocurrencies on our same proof of space format. We want our farmers to already be set up for everything else. I think our farmer community
讲了一
really,
个
really wants that. We have definitely gotten some
矿池相关
very,
的问
very
题，
clear messages from our community
就
that
是
they
就是
they
能不
don't
能
like
把你的
replotting,
图
they
借给
really
别
want
人
it.
用？
So there's very, very clear messages we've gotten.
这个问题其实我原来也想过。
For the current plot format that everyone's using right now, which gives a pool, that gives a pool public key, that will work. That's trivial to co-farm on other things. For our new format that allows you to port between pools, that's done by doing a puzzle hash. The problem with that one is that the singleton that's going to point to is going to be very specific to our blockchain. You're not going to have the exact same singleton on another blockchain. However, there is a thing that can be done here, which is basically everybody has a local key and a farmer key in all of their plots kind of.
但是你也不能说你就不屌啊，不屌的话，那到处那谣言给你传上天去，肯定得出来就是回答一下、解答一下的，不可能完全不屌的。
changing anything at the protocol level, but we're tweaking the format of plots that use a puzzle hash prior to launching.
现在这网络时代，
so that it will be
你不回答问题，那就代表你默认。
to really to say here is the local key and farmer key that was used to make this plot key that's in this particular plot. In that way, something that's co-farming can just kind of treat the farmer key as basically a pool key, and so that you as a farmer can have some state on chain that's pointing towards the plot that your rewards are currently going to. That doesn't have quite the same elegance.
他的解释，而且从技术角度上来讲，它这个东西确实是可以破解的，只不过是经济角度上来讲，没有破解的价值。
That you replot every time you want to support another another cryptocurrency, and pretty clearly people don't want to do that. And cryptocurrencies that might, no other cryptocurrency supports it yet, so you can't, and we don't know which ones might, so you can't really prepare for that in the future. So it's the best solution that we can do is make it so that at a slight hit of elegance in other cryptocurrencies.
但我根据我的经验来讲，他们只要能发现问题，应该都可以解决。最差，最坏情况来个硬分叉，那也不是啥问题。
What this does. The downside of this, and I want everyone to get a heads up on this, because this shouldn't cause pain for much of anybody, but people who have plotting utilities that they're maintaining really should be aware of this. That the format for plots that use puzzle hashes is very slightly tweaked. And we really don't want people using the old one after we get pooling protocol out, because although that will work, it means that if these people who have used it want to use another cryptocurrency that switches the proof of space in the future, they might have to replot those plots to get those rewards. So please, everybody who's maintaining plotting utilities, get this stuff.
他是在给一些这个做代批的人一些建议。我刚才好像没太听完整，他好像说他这个将来可以给别的币去 P 图。我不知道是不是就像以太坊一样，如果有别的币在他这个公链上面发行，是不是他这个图也可以就是去给别的币去用来去挖别的币。
Then even if other cryptocurrencies decide to go ahead and switch to proofs of space, you'll be able to farm it no problem. And
I just want to emphasize, Bram, that if you are self-pooling, like currently most people are, you don't have to change anything.
Oh yeah, that's
still work.
这有点意思。他意思是别的加密货币如果想转成他这种算法，它可以就是你已经批好的图可以用来去挖别的加密货币。
The theory behind K33.
这我想想，理论上讲，应该是有那么点可行性的。
One of them is that if you really want to fill your space,
因为本质上你只需要一个空间证明。
You can figure out the right ratio between like the right number of pairs.
想法有点意思。
K33s to like almost exactly fill up the available space on your.
这他以前好像没提到过有这功能。
Other theoretical benefit is if like storage really gets fast in the future and you have like
这应该还比较远，离我们还比较远。
In the future, no, most likely.
你能想象有一天用这个你 P 的图去挖 ETH 吗
？But if in principle, if you had spinning disk with some ludicrous space on it, then you would get completely killed by the number of lookups you have to do for it, and you might want to use much higher Ks to reduce the number of seeks that you have to do. That's looking highly unlikely at this point, but we wanted to make sure that we were ready for such theoretical things, because when you are making something that's supposed to run until the end of time, you have no idea what's going to happen.
A somewhat related question is, is it easy for these people making other plotters to do these
我
changes that we're currently
我
talking
比较喜欢
about?
听
And,
这个
the
Brian
quick
讲，
answer
因
is
为他有
yes.
时候讲
These
着
are
讲着
just,
老是会
minor
感觉
changes
会
to how the keys are
泄
stored in
露
the
一些
headers.
东西，
And, we'll be documenting this very
他
well.
嘴上
It's very, very easy
感
to
觉
make these changes.
不是特别严。
Yeah, if they've
还有时
already
候会
worked in
讲
the
漏一
code,
些
it's
东
just
西。
merge back. That's great.
Yeah. No, look, our goal is to try to make this
其
as
他
portable
人
as
讲话
possible.
都
We
很
identify
官
the
方。
portable pool plot issue as yikes. That makes co-farming difficult, and we really don't want that. We want, from an environmental impact perspective, to let other people who don't care as much about the consensus algorithms proof of to, be able to move to this and leverage, everyone here. But we also have to be careful just because 51% attacks are a real issue that people have to think through about getting y'all farmers to adopt. So if not enough of you adopt, then all of a sudden some of our whales could, for example, take over other people's chains. So, we wanted to make sure that we've thought through all those issues so we could get people to onboard and move over. Let's see. I believe we're kind of catching up on these questions. Bram, a question that always kind of pops up and it's related. Can you talk about the quantum hardness of Chia and where, its vulnerabilities are and what we kind of think about it?
越来越玄乎了。
So there's two places where there's real quantum attacks in Chia.
他现在开始
Number one is
有人问这个
the,
量子计
DLS
算是否
signatures,
能破解它这
and
个东
number
西，
two is on the VDFs. It's important to emphasize for both of these. These are very, very theoretical.
越讲越扯了。
And they're kind of analogous to you have also SecP signatures in Bitcoin are not quantum safe.
因为最近好像传出来这个量子计算可以破解这个比特币的这个
It
POW。
appears to be that quantum breaks in practical cryptography are looking a long ways off, if ever. The practicality of these is highly dubious. We are doing in our keygen for our public keys. We're doing some steps where there's like a winternet signature in there that's just hashed for the next step. So there is in case of crazy emergency, break glass option of making it so that basically all the signatures are invalidated and you just have to start revealing your private key, but not the private key behind that, and you use that to sign things. That's something you don't really want to do. There are other, however, when you have that, there's another cute thing that you can do because there's a hashing step in there. If everything gets broken, you also have the potential to have, if there's some like post-quantum snark thing that you can do, you can have, you can generate a proof that you have the pre-image using this post-quantum snark that you're using, and use that to effectively sign something. Our VDFs are actually in much less danger than those because you have an extremely short period of time to attack a VDF. It's gone in 10 minutes. So not much. That's much less worrisome, and it's not directly defending stuff in the same way.
反正他意思就是他这个 POST 相对 POW 来讲，对量子的这种量子计算的这种破解的这个抗性还是相对高一些的。
Quantum resistant cryptography you adopt today, is just going to be really bad in a couple of years. There are much better things that are going to be available in the future because the state of the art has been improving a lot very fast.
我觉得下一代这个加密货币肯定得考虑这个如何防止这种所谓的量子计算计算的这个硬件去挖矿啊或者什么破解，不然的话，基本上目前这些加密货币都得崩了，尤其这种 POW 的最容易崩。
So a couple things that are kind of floating in the community I just wanted to quickly respond to. People are asking, hey, can you use both types of plots in the future, the ones that you built already and the ones that assign to pools? The answer is yes, they'll co-farm in the same wallet. And the other question was, if I go to a pool, can I move back to self-farming? And the answer is absolutely yes. You actually could replot to self, and that's probably the first thing that'll be available shortly. But the whole point behind the portable pooling plot is any pool, including yourself.
Yeah, no. Our pooling protocol allows you to jump pools. It allows you to switch the parameters so that like pools can have different policies about the amount of time it takes to exit them. There can be pretty much arbitrary things that actually it's actually paid a singleton, so you could make it so that like your rewards are going to a rate limited wallet if you set up for pool to begin with. That's getting pretty fancy. We're not putting that in the UX right up front. But actually, we
它
have
的
this
这
really
个
amazing
新的
on-chain
矿池协
programming
议还
environment,
是
and we are completely dogfooding it
有
and
一
try
些
to
隐
leveraging
藏
it
功
very,
能，它
very
刚
well
开始
for
是
pooling
不会放
protocol,
出
which
来
is our
的，
first big project.
一开始就
But using
是
it
切换
for
矿
actually
池，
like
但是
rebuild
它其实
prototypes,
还有很多其他的功
which
能。
is how we know how to actually do this stuff pretty well. But this is our first time really building something big and deployed.
Great. So, Bram, I think there is one question people are asking, which is, if we had to change the filter, would that be a fork?
Yes, but probably not a terribly contentious one. It wouldn't actually cause pain for much of anybody other than people having to upgrade their software.
Yeah. And it would also probably have a very long activation window. Let's see. Other questions.
I have a couple that I collated. People are asking about Chia plot check. Is there some warranty that can give to the Mad Max plots? Like how can they validate the Mad Max or any other third-party plots work, and we'll farm Chia for them?
We have our command line filter or a check. Yeah, what's it called? The
Chia plots check is what it's called.
Chia plots check. Yeah, we should probably put that in the GUI as well.
有人问
Yeah,
想让官方出一个
I was
工
gonna say,
具
yeah,
去
you can
检
run
验
the
这
Chia
种
plots check on the
第三方
the Mad
的
Max
批出来的
plots and see
图是有效
over
的。
a large number of iterations that they do perform. As far as we can tell, they do perform pretty well. Again, community members are designing tools that will do an exhaustive search through all the challenges in the plot file to see how they match up with the stock plotter. That's just part of the vetting process. It's going to take some time because obviously it takes a while to run that exhaustive look through the plot file. The main problem we have with the Mad Max plots is that they're not byte for byte identical with the stock plotter, so it's taking us a while longer to validate it. That doesn't mean that they can't still work. So.
There's a question floating around about whether BIP39 has an issue. If you would, please follow up later on Keybase with what you're pointing at. We're actually not implementing BIP39. We're actually implementing EIP 11 something. So we're actually using the Ethereum 2 standard for BLS signatures. And we have... Was it?
Might be implementing an older version of it because we got it deployed.
We shipped before it was final. The one difference between the final and ours is that the opportunity to salt or password encrypt is not down in the key. It's up above in the application for us. So
probably
that happened after our plots were finalized during testnet, which is like about almost a year ago. And so that gives you an idea of how committed we are to keeping plots valid.
Right.
Another question they asked about if we could address the concerns that they've heard in the community about double farming on the mainnet and how that, if that applies, if there is any concern to that kind of an attack.
So our pool protocol is very specifically designed to not have problems with double farming. If you are trying to design a pool protocol where people can have already running plots,
就新的矿池协议是不可能双挖的。
these things that they've already plotted to self-pooling using the old format, which doesn't have a singleton that it's paying to on the blockchain, that inherently will have double farming in it. Those are going to be pretty crappy protocols. So I think it's a pretty high likelihood that basically everyone, including current pools, is going to try and switch to our new pooling protocol once it
这其实是一个不太好的消息。
gnarly inherent
就是矿池，现在的矿池为了防止双挖，他们都很乐意去切换到新的矿池协议，因为新的矿池协议可以防止双挖。
double the capacity and actually win any meaningful rewards on the actual network. This is trying to trick certain unofficial pools into thinking you have more space to get more pooling rewards for the pools that are unofficial today. So nobody can actually fake space on the actual real network. That's, as Bram said in his Twitter, that creating a false proof of space is not possible.
Yeah, you're not actually fooling the Chia blockchain, but you are stealing from other farmers within that pool.
Yeah.
Also, you can fool your own UI. Your own UI is not aggro about trying to make sure that you have the right number of space. So if you take the same plot,
啊，他
and
就
you make
开始
15
讲
copies
那
of
个
it,
假
and
算
since
力
you
的
have
事情，
1,500 gigabyte
就
plot,
没有人
you
能
go-
够
you have
欺骗主
Yeah,
网。
congratulations, you fooled the UI.
你可以
but you're not
骗
gonna be
你
able to
自己
make
的
That's right.
UI，
You'll make 15 plots.
可以
15
骗
proofs
矿
is exactly
池
right.，
Yeah,
Bill,
但你骗不了主
to clarify
网。
the nature of the attack, if you have a pool protocol that's based off of partials, which could be done today, I can't vouch for what the existing pools are actually doing. I'm not making any claims about what they're actually doing, but they could be checking partials, which aren't terribly fakeable. The thing that they can't really stop you from doing is just running your own farmer, pointing at the exact same their client is, and then you might sometimes win, and your farmer is the one that makes the block rather than theirs. Looking at the exact same plots, so now you're getting credit for having these plots, but in the cases where you actually do succeed in making a block, you might just get to keep the block. They might kick you out of the pool for doing that, but you might have been small enough that it's an unlikely circumstance where you actually make a block anyway. Also, similar attacks where you have multiple pools and you just join all the pools and just get credit for your work in all the pools. And so you're giving legitimate proofs of space to all of them. You're just kind of double dipping across all of it.
So, Bill, a question. Could somebody try to use an FPGA or an ASIC with high-speed memory to somehow create phase one of a plot faster than a GPU?
Well, I mean, obviously, if NVIDIA wanted to design a system specifically for us, I mean, that could be a possibility, but we're talking about cost here as well. I mean, whether it can compete with hard drives, not likely for most cases.
Yeah. The other thing is that FPGAs
他们
and
在
ASICs
讲有人会不会
so
用
to get high
FPGA
bandwidth
或者
quantity,
ASIC
you actually have to
专门
create
做一
a
个就是针对他们这个算法的
for more flash
一个
channels.
P
That's
图
actually
的
consumes a
硬
large
件。
percentage of the actual area in the ASIC, which the area is directly proportional to the cost. So if you wanted to make some high bandwidth ASIC, it would also be high cost and high power. So these are all the trade-offs. Just with the plotting being so
他
memory
们
and
觉
IO
得
intensive,
是成本
not
太
that it
高。
can't be done on an FPGA, but being done fast, you're still
当
limited
然
by
说白了
bandwidth, which
，FPGA 这块
may
我也
not
不
be
是特别懂，
something that's going to be cost effective.
肯定是能做出来，但是成本确实不好说。有
Yeah,
的
And
是
it's doubtful an FPGA is going to be able to do this. It would be an ASIC, if anything.
That's right. And Blake
That's
3
right.
and Cha-Cha 8, which are the kind of primitives that we use here, are just intentionally designed to be extremely efficient. So it's not clear there's a huge step up from custom hardware from even the Cha-Cha stuff that's coming on the next generation of Intel processors on acceleration. So
At some point, if someone's really trying to grind like super fast, like
哎呀，矿池什么时候出还不
the
知道。
costs of power are going to become dominant over the cost of their hardware, and there's just we can only
你
get
们
so
聊
far
新
from
项目
the
可以
manual
到
removal.
那
It's
个那
just
啥，
gonna cost you
有个频道专门聊新项目
power
的，
to
我看到
do
没人
that,
聊。
and you're making a faster system is just going to be doubling the cost every time you double the speed because it's going to double.
yeah, look, if you have a $1 billion budget, you too can create a petabyte, or you could just buy a petabyte for a lot less. In fact, you buy a lot more petabytes for $1 billion.
Or just buy a couple Oak Ridge supercomputers, right?
Right. 300 million later.
You do that today.
The old joke in quantum computation.
这个理由我觉得是说得通的。就说你如果有钱，搞一个那么牛逼的，就花几百万搞一个特别牛逼的 P 图的机器，你还不如把这几百万花着去买硬盘，就是买这些P 盘的，不是 P 盘的，这个 Farming 的这个机器实在一点儿。我觉得这个点倒是
Okay, I think we've got most of the
比较
questions
合
answered
理。
here. Obviously will be available online. The nice thing from our perspective is that we're aware. It's something we've thought about, and we have the knobs to turn if we have to make changes. But ultimately, proof of space and time is a well understood problem. There is no real magic way to stop it. To the extent that we
现在
cause
在做
people to
总
cause
结
memory
发言
buses
了
to get a lot faster.
基本上就是说，他们这个会议的目的就是说，他们注意到这个问题了，而且他们对这个算法其实是很了解的。 没有
it's a
人
big
可
risk for somebody
以
doing that because
就
with a
是
simple change to the software,
用
it
什
would be
么
validated. So, from
魔
that
法之类
perspective,
的
we
东
don't
西
worry
绕
about it
过
too
这个
much.
东西，他们应该是心里有数的。简单来讲，就是这个意
Thank
思。
you, everybody. I will say the only thing we'll say about pools is it's very soon. There's put in quite a bit of work. If you take a look at
他
GitHub,
只
you'll
是
see
说矿池
that
快
there's
出来
been a
了，
tremendous amount of activity on it, and
但
we
他还
should
没
be getting
没
those
给
things
时间
out。to the pool operators very soon now. Thanks, everybody. Have a great night. Thanks.
Bye, everybody.
结束了。对呀、就是说，如果你有这个那么多钱去搞这些乱七八糟的 GPU P 图，或者说专门搞一个集成颠覆器 P 图，你还不如把这些钱花了去买硬盘实在点，又稳妥又就是又可持续的时间又长。因为你用那种方法就是挖的话，你挖的成本是非常高的，你就耗电量是非常惊人的，你不可能太长久的。Very soon 比 soon 好。行，今天就先到这儿。我完了，我还得再回看一遍，看看有没有漏掉什么，然后做个视频吧。行，你们聊天的可以去 Discord 上面聊，我直播要关了。